Okay, hi guys. So in this lecture, we'll be starting off with a new topic, which is KC and TC, or kinetically controlled and thermodynamically controlled reactions. Okay, so let's get started. So we have KC and TC, which is nothing but kinetically and thermodynamically controlled reactions. Okay, so let's see an example. We have, suppose, this compound. Okay, and we are reacting this compound with HBr at minus 40 degrees Celsius. So what would be the compound formed? Obviously we'll get a positive charge here, and this alkene group will act as a nucleophile to this electrophile, which is H plus. So we'll be getting something like this compound, Br here and CH3 here. Okay, so this is 1-2 addition. Okay, and this compound is actually kinetically controlled. Okay, now if we react the same compound in HBr with HBr and in 25 degrees Celsius, so we'll get something like this product, CH2Br, which is actually thermodynamically controlled, and it is 1,4 addition. And it is actually thermodynamically controlled. Yes. Okay, so let's actually see how these two different products are formed because of difference in temperature. Okay, so let's understand the mechanism behind the scenes. Okay, so we have something like this was the R compound. Okay, and we were reacting it with HBr. So what would be the intermediate? Intermediate would be nothing but this would be the intermediate. Okay, with H atom attached at this carbon atom, and after this intermediate we'll be getting something like this intermediate will be reacting with Br minus. As a result, we'll be getting this compound. Okay, it is kinetically controlled. Okay, so now actually what happens if the intermediate actually undergoes some rearrangement, in which we get something like positive charge at this carbon atom, double bond here and single bond H here, which is also a rearrangement of intermediate. Now Br minus actually happens to attack this carbon atom, and so we'll be getting something like Br here and H here. This is actually thermodynamically controlled. So if you compare the two outputs, so in the intermediate stage, or in the intermediate state, this is obviously more stable. Hence the compound which is formed as a more stable intermediate will be kinetically controlled, and the compound which is more stable in the product will be thermodynamically controlled. If you calculate the stability of these two end products, you will see that thermodynamically controlled product is more stable than kinetically controlled product. Okay, product stability, obviously because it has more alpha hydrogen than this compound. Okay, but kinetically controlled product is more stable than thermodynamically controlled product as a intermediate stability. Okay, so this is the two different things we should keep in mind while deriving KC product or TC product. Okay, so let's actually now see the reaction coordinate. So we have something like this. So this is with time, or rather states, different compounds. Okay, so this was our initial state. What will happen is we must give some activation energy. It will form an intermediate. Will have something like partial double bond in each of the carbon atom and delta plus on the extreme ends. Now what will happen is we'll get Kc product by having less activation energy, and we'll get Tc product by giving more activation energy to the compound, but the end product will be more stable. Okay, this is thermodynamically controlled and this is kinetically controlled. Okay, we need less energy from the intermediate state to get to the Kc product, and we need more activation energy from the intermediate state to get to the Tc product. Okay, but the end product stability would be that Tc product is more stable than Kc product. Okay, end product. Okay, so this is how the energy coordinate looks like. So just to summarize these points, I'll just write some notes here. That first, that at low temperature reaction is kinetically controlled, major product is decided by the intermediate stability. So at low temperature reaction is kinetically controlled and the major product is determined by, or rather is decided by, intermediate stability. Okay, and second point is at high temperature reaction is thermodynamically controlled and the major product is decided by product stability. At high temperature reaction is thermodynamically controlled and major product is decided by product stability. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples on the product stability and intermediate stability, deriving the products and products, and then we'll be seeing Friend's rearrangement. Okay, so till then, good luck and goodbye.